Hello students, a very good morning. In last class we have ended our topic for the motion in straight line. So students, in the case of motion in straight line, what we have understood, wherever some of the object is here and that is moving on some of a straight line, and if point mass concept we are taking, then we are calling it rectilinear motion. And in that case, what is speed, distance, velocity, accelerated motions, uniform motions, and their graphs we have seen all, and some equation of motions we have seen. So now let's start our next chapter exactly, that is motion in a plane. Now we are going to put our concern over the motion in plane. Means if one or two axes are here, if body is moving along any plane, then that which kind of motion it can perform and how can we understand that one. So let's understand that, and before seeing anything, again as I told you, we will discuss vector in details here. So here as scalar and vector, two types of physical quantities we have. So a large number of physical quantities that can be classified into two categories. First is scalar. So you know what is scalar. These are those quantities which has only magnitude but no direction, like mass, time, work, etc. And vectors are those physical quantity which have both magnitude and direction. So here this is very important concept, and we have understood this for velocity, acceleration, and even displacement. We have all seen that there is some particular directions associated with that. So graphically, if you have to just represent any vector, then we are representing it by a straight line. In this way we are using the straight line with the arrowhead with this one. So if some of the quantity we have, suppose f is the quantity, and if we will put this arrow vector over it, then that this vector or this quantity is known as vector quantity. So this is the way to represent the vector quantity here. Now let's see how many types of vectors we have. So vectors are also two types. First is polar vector, second is axial vectors. So what is polar vector first? So polar vectors are those vectors which have a starting point or a point of application and act along the direction of motion of the body. So like for example, displacement, force, all are polar vectors. So in the case of polar vectors, as I think now this is simple, they have such a starting point. So displacement is started from a point, force is started from a point. So these are all polar vector. Now the second one, axial vector. So axial vectors are those vectors which represent rotational effect and act along the axis of rotation in according with the right hand screw rule. So if here you can see now the rotations of clockwise or anti-clockwise rotations are given, and if you will see the direction of their rotation, then the area vector we are calling exactly, that is passing perpendicular to the area or perpendicular to the, you can say, the axis of the diameters of this rotational field. So it means this is now our axial vector. So for example, where axial vector we can use in case of angular velocity, angular acceleration, torque, angular momentum, whenever rotational concept we will have, that time this kind of vectors we will have. Now let's see why vectors are important, why we are studying this one. So here you can see now the importance of vector by these three following lines. So first line is, many laws of physics can be expressed in compact form by use of vector. So we can just write down the law of physics in very compact form by using them. So we're there to write the physics law in a compact manner, we are using these vectors. Second one, the derivations involve many law of physics can be greatly simplified by the use of vector. So in simplifications we are using this. Third one, the law of physics which expressed in vector form remains invariant for translation or rotational of the coordinate system. So if we will change the coordinate system, if we have expressed them in vector form, that will not change, and that helps us to see the invariant property of the quantities. So this is this made our physics and this law as the universal laws. So you can see now the importance of vector in physics, that is very huge, that can make our laws simplified, universal and compact. Let's see the next one here. Some definitions related to the vector algebra. So the actually analysis of the vector in mathematics, we are calling that vector algebra. So let's see some of the terms that are very important here. First is modulus of the vector. So the if you will see the magnitude of vector, then that is called modulus of that vector. Modulus means if we are making some of the vector as a scalar. So if we are calling that 20 meter per second velocity due east, so if we will remain just to suspend due east word, we will say only 20 meter per second, and that is, or 20 is the modulus of the vector velocity vector. So it is represented by this one. You can see represented by modulus sign or a. Now next one, second is unit vector. So unit vector is what? A unit vector of the given vector is second one, what is unit vector? So a unit vector of a given vector is the vector of unit magnitude and has the same direction as that of the given vector. So it means that unit vector has the same direction as the vector. Suppose vector A we have, and we are calling actually by name this one vector A, then its unit vector is represented by a cap. So we are calling a hat or a cap, and a cap is defined as whenever we are multiplying unit vector in modulus of the vector, then that is providing us the vector. So simple unit vector can be defined as the vector divided by modulus of the vector. Now here if you will see the unit vectors that are just associated with certain axis, like here with x-axis we are calling the unit vector as I cap, for y-axis we are calling it the z cap, for z-axis we are calling it k cap. So I, j, k caps are the unit vectors associated with the Cartesian coordinate system. And one more thing, unit vectors if you will see, that are unitless and dimensionless vectors and represents only directions. So if they are used to represent direction somewhere. If I cap is written, it means simple, it is representing x-axis. If j cap is written, it means it is representing y-axis. K cap is written, it is representing z-axis. So it is giving us the direction of, you can say, the direction. Now important note is given here. First magnitude of unit vector is unity. So if you will just find out the magnitude of now unit vector, so this magnitude is find at unity always. Second one, a unit vector has no unit and no dimension, so that is dimensionless and unitless quantity, that just now I have told you. Third one, a unit vector of a given vector tells the direction of that vector. This one also I have told you. Now here a sample problem is given. Let's see now this problem. Find the unit vector of this vector, that 4i cap minus 3j cap plus k cap. So let's find out this one. So to find out the unit vector of this, first if suppose this is the vector A, and vector A is 4 of I cap minus 3j cap plus k cap. So as unit vector, A cap is defined as vector A divided by modulus of A. So what we have to find out? We have to find out mod of A, because vector A is already given. So modulus of A, how can we find out? Modulus of A is find out by taking root of all the components. So first component, that is multiplied with I, this is 4, so 4 is square, plus the second component is minus 3 square, if you will write, that is 9, then third one plus 1. So here finally if you will solve it, then this is obtained as root 26. So this is our modulus, and now finally if you will write down with the help of this one, this is now the unit vector. So in this way unit vectors can be calculated easily. The third definition is equal vectors. So let's see what is equal vector. So two vectors are said to be equal if they have equal magnitude and same direction. So here you can see in figure we have two vectors A and B. So these two vectors, their magnitude, their length, it is that is showing equal, and that they have both have same direction. So that time we can write equal vectors by vector A is equal to vector B. And here one more thing, the angle between equal vectors you will see that is 0 because they are in same direction. So next one here, if for fourth one we will see that is negative vector. So negative vector of a given vector is same in magnitude but now acting in opposite direction. So suppose one of the vector is this one, this is suppose vector A, and vector B is this one. So this is now the vector B. So both are same in magnitude, same in length, but their direction is just opposite, so they are calling negative vectors. So for negative vector, if you will see the angle between them, the angle between them is equal to pi radian or 180 degree. Now let's see the fifth one definition, that is co-initial vectors. So the vectors are said to be co-initial if their initial points are common. Like in this example, in figure this you can see the initial point is O, a vector we have drawn OP and a vector OQ. So OP and OQ, they have common point now, so that are called co-initial vectors. Now let's see the next one, that is collinear vectors. So these are those vectors which are having equal or unequal magnitudes and acting along the parallel straight line. Only here they have to be parallel, they will be collinear. Means they are you can see all these examples are given here. These all are the examples of collinear vectors. So here in first one, as they are parallel along the same direction in sex A, in B they are parallel, you can say, along the same direction, and now they are in opposite direction. Now next one, let's see coplanar vectors are what. So those these are those vectors which are acting in the same plane. Only if three of the vectors are acting in same plane, like here in this figure you can see they are acting in same plane of paper, then they are called just coplanar vector. Now next one is localized vector. So it is that vector whose initial point is fixed, it is called the fixed vectors. So if initial point is fixed, that cannot be changed, then that type of vector is known as localized. And if initial point is not fixed, then that type of vector is called non-localized or free vector. Now let's see the next here vector, that is position vector and displacement vector. So here in this figure you have to see, in figure you can see two OX and OY, two of the axes we have, a plane we have. So in this plane, if A and B are 2 points, so if this is our plane X, this is O, this is Y. Now 2 points we have A and B. So this is B point, this is now A point. So the position of point A with respect to the origin, this is if we will draw a vector from O to A or a straight line with arrowhead, then this OA is known as position vector of the object A. Similarly, if we will draw the position vector this OB, then this OB is representing the position vector of B, means it is giving us the position of B. Now what is displacement vector? The distance between A and B point is called displacement. So here we can draw a vector that is representing the distance between A and B. So that is called the displacement vector. So I think the displacement vector and position vector, there that difference is now clear to you. Now next one, let's see here the multiplication of a vector by a real number. So if here suppose n is the real number that is multiplied in a vector A, then that time the vector becomes direct NA. Means if we will multiply any of the vector, then that vector again becomes n times to the vector that it was before. So simple vector will be multiplied. Like here in this figure, if you will see, initially we had the vector that is A. Now this vector is multiplied by 2, then its magnitude is now just doubled, 2A, you can see. Similarly here this vector is again A, we have multiplied it by -2, so its direction is opposite and its magnitude is now doubled. So simple, you can see its magnitude is just increased by that number of times through which it is multiplied. Now next one, multiplication of a vector by a scalar. So whenever a vector is multiplied by a scalar, then it becomes SA. Here if some of the scalar quantity we have S, then that it directly becomes SA. So here for example, if A vector is given 100 Newton due west and S is given 10 second, so SA will be what? This is 10 second and 100 Newton due west. So overall what we will get? 1000 Newton second due west. So this is simple multiplication of scalar will be simple multiplied by, into the vector. Now the next type of vector, let's see, that is resultant vector. So resultant vectors concept we will see whenever we have two or more vectors. So if two or more vectors are in our space and we want to remove or we want to just reduce our complications, then that time we can represent number of vectors by a single vector, and that single vector is known as resultant vector, that is representing the resultant effect of all vectors. Now next topic is very important, most important word you can see. This is now vectors addition is not possible by simple law of algebra. So we cannot add simply the vectors by simple law of algebra here. Like you can see now one of the example. Suppose consider a particle is first displaced through the 4 meter due east, then 3 meter due north. So let these displacements are represented by PQ and QS. So here in this figure you will just see particle is now first going through the east. So due east it is just going from P to Q, the 4 meter distance, then from Q to S it is going 3 meter. So that is the north distance. Now if you will see what is the position of our particle from the starting point, means how much the displaced the particle is. So displacement of the particle will be PS, not PQS. So if simple algebra you will use, then you will add PQ, then QS. So according to this one, the displacement should be 7 by simple algebra, but here you can find out by the Pythagoras theorem the distance of PS. So the magnitude of PS, this is calculating by 4 square plus 3 square. So this is obtained as 5, and this is the real answer. Exactly our system particle has displaced from its initial position by 5 only, not by the 7. Simply you can see now, if we will use the simple algebra, mathematical algebra, then that time vectors addition will be wrong there. So vectors additions that cannot be done by the algebraic method. So we are using some different methods for this one. So let's see now the methods of vector addition. So the first method here you can see the vector addition by geometrical methods. So in geometrical method, general rules for addition of vectors are, it states that the vectors to be added are arranged in such a way that the head of first vector coincide with the tail of the second vector, whose head coincide with the tail of the third vector, and so on. Then the single vector drawn from the tail of the first vector to the head of the last vector is the resultant vector. So this this can be understood by this one example. Now suppose we have two vectors A and B. So A and B you can see now, according to our statement, now A vector can be written then over the head of the A vector. Here you can see the head of A, we have to put the tail of B. So we have put the tail of B, then again head of B we have obtained here. Now finally you can see here the tail of A and head of B. So this is the whole is representing now the resultant vector. So this is the vector addition of those two vectors here. So this is A plus B vector. the second one, when two vectors are acting in opposite direction. So that was the example when they were acting in same direction. So suppose we have two vectors A and B that are in opposite direction, then that time first you have to just put the vector A here. So if you will put the vector A, then this is the tail of vector and this is head of vector A. So this is head of vector A, and now you have to put the tail of vector to the head of vector A. This is our rule. So tail of vector B, that is this one point we have put here, and then head of vector B is here. Now you can see this vector will reduce the first one by this amount. So this we will obtain this amount, this one. So we will obtain the rest of the vector. This will be, so this is the A minus B. So in this way you can understand in the subtraction of the vectors, our vectors are in opposite direction, then they are subtracted exactly. Now if when two vectors act at same angle, so similarly we have, suppose two of the vectors A and B, they are acting actually same angle, not some angle. So here they are acting at some of the angle, then that time how can we find out their resultant? So suppose A and vector B are at some of the angles, then that time first we will again use the same rule. First we have to write the vector A, so and the head of the tail of vector B we have to put to the head, and that time we have to make the vector B. Now it's a resultant, you will just add or meet tail to head of the second vector, then this will represent the resultant of this one. And another method of to just represent the resultant, that is we can make a parallelogram. So here this is our vector A, this is vector B. So the if you will see some of the another two vectors can be drawn to make a parallelogram, then the diagonal of parallelogram is representing the resultant. So here a triangular method or a parallelogram method, two methods we are seeing for the vectors when they are at some angle. So let's see now, just a second. The triangle law of vectors. The first triangle law of vectors states that two vectors acting on a particle at the same time are represented in magnitude and the direction of two sides of the triangle taken in one order, and then resultant vector is represented in magnitude and direction by the third side of the triangle. So here like in this figure you can see we have represented by two sides of the triangle, then the third side representing the resultant. Now let's see the second law, that is parallelogram law of vectors. So it states that if two vectors acting on a particle at the same time are represented in magnitude and direction by two adjacent sides of the parallelogram drawn from a point, the resultant vector is represented by the diagonals. So here as in the figure, this one I have told you, this one case we can represent by two sides of the parallelogram the two vectors, then its diagonal will represent the resultant vector. So these are the two methods to add the vectors or to find out the resultant of the vector. Now let's see the next one, that is when numbers of vector act in different directions. So if suppose we have four vectors A, B, C, D that are acting in different directions, then what we have to do? Again we have to do the same procedure. First put A, then put the tail of B to the head of A, then again put the tail of C to the head of B, then put the tail of D to the head of C. So in this way, and they, with the help of their directions, if you will just find out. Now what you have to do, you have to use the tail of the first one A and head of the last one D, match this one. So this the vector that you are seeing at last, this is representing the resultant vector of this one. So this is called the polygon law of vector. So I think polygon law of vector, that is also now clear to you. Now the next one here, let's see analytical methods of the vector addition. So in like just now we have seen the graphical methods, let's see how can we represent by the analytical method. So here the first triangle law of vector addition, again let's start with this one. So for triangle law of vector addition, we know that if we have two of the sides of the as the vectors, then the third one is representing as the resultant. So suppose OP here in this figure, OP is vector A, PQ is vector B, and OQ is vector R, and the angle NPQ. So NPQ, you can see now we are just putting one of the perpendicular from Q to this OP, then that time this is angle theta that we can see. So here we can calculate the value of cos theta. So in the triangle PNQ, value of cos theta will be equal to base upon hypotenuse, then Pn upon PQ. So here as Pn can be calculated from here, so Pn will be equal to PQ cos theta, and PQ has the value B. So BQ, B cos theta. Similarly, we can find out the value of Qn. So value of Qn by using the sin theta. So here it will be equal to B sin theta. Now let's just right angle triangle ONQ we have, sorry, yes, ONQ, this right angle triangle you can see. So in this right angle triangle we will have this OQ as it is hypotenuse. So hypotenuse square is equal to base square plus perpendicular square. So base is ON, perpendicular is NQ. So ON can be written as OP plus PN, and NQ can be written as it is. Now here OQ as it is equal to R, so it will be R square. So we can write R square, then ON that is written at OP plus PN. So OP, this has value A, and PN, this has value we have just now calculated, B cos theta. So B cos theta whole square. Now the next one plus NQ square. So this is perpendicular square. So NQ has value that we have calculated, B sin theta. So B sin theta whole square. Now what we have to do, we have to open this whole square. So this will be A square plus B square cos square theta plus 2AB cos theta. So finally R square, this will be equal to A square plus B square cos square theta plus 2AB cos theta, then plus B square sin square theta. So this one here from the B square can be taken as common. So that way when you will take B square as the common, then R square can be obtained in this way, and or R can be calculated as root of A square plus B square plus 2AB cos theta. So this is the way, analytical way to find out the resultant of two vectors A and B if they are acting at the angle theta. And if you have to find out what is the direction of resultant vector, so the direction can be calculated as like tan beta. So beta is what? You can see now this angle is beta. So if beta you will find out, then that will give you the direction of resultant. So tan beta in the triangle ONQ, you can find out that is QN by ON, and QN has value B sin theta. ON can be written as OP plus PN, that is A plus B cos theta. So in this way you can find out what is the direction as well as what is the resultant magnitude. Now let's see the second law here, that is parallelogram law of vector addition. So in this case, as a statement you are familiar with, let's see the derivations here. So in this here you can see A and B are two vectors, and these two vectors are two sides of the parallelogram from the single point. Then R is the resultant that is represented by the diagonal. Now what we can do, we can take theta between A and B angle. Beta is the angle, direction of R, and now here you can just extend this one, then Pn this will be, and this is equal to theta, and now this angle you can see this is now alpha, and one of the perpendicular we have drawn Pm over this one. Now what we have to do, we have to again find out in right angle triangle ONQ. So OQN, this one is we have. So in this case OQ square you will find out this is ON square plus NQ square. Again ON can be written as OP plus PN, then NQ. So here OP, this is value A, and Pn, this can be calculated by the triangle QPN easily. So that will be equal to B cos theta, and now you can see NQ is equal to B sin theta. So you can solve it, and again you will get the same formula as we have got for the vector law of triangle case. So this is all the case that we have found out the direction and the resultant of the vector here. So here from equation 5, if you will see cos theta, so value of cos theta can be calculated in this one. This is known as law of cosine. So we can also represent the law of sines in this different form. So law of sines can be calculated by the method that is written here. So this is exactly this one that you are seeing. This is called the law of sines. So r by sine theta, that was equal to a by sine alpha and b by sine beta. So this kind of figures we will obtain whenever three vectors are acting. Suppose this is our vector A, this is vector B, this is C. So here this angle is alpha, this angle is beta. Suppose this angle is now gamma. So according to sines law, A upon the angle in front of A is beta. So this is A upon sine beta. This should be equal to B upon the front angle is gamma. So this is sine gamma, and then is equal to C upon the front angle is alpha, that is sine of alpha. So this is called the sine law. The law of sines and cosines are now clear. So with the these discussions, now how to find out the resultant of any vector by graphical and analytical method, let's today end our class here, students. In next class, let's discuss the rest of the things about the vectors. So thank you, students, for today.